What's up, Bulldogs? It's Thanksgiving, and I'm doing math. Woohoo! Oh, sorry about that. That's my my pet turkey must have gotten out of its cage. I don't really have a pet turkey. All right, let's do two problems here. 11 and 16 from our partner review. Here we go. We're given some information here from 1990 to 2000. That is 10 years worth of time. The number of thousand visits by people to Hawaii Volcanoes National Park increased by 43.1 thousand visits per year. That means each year it goes up by 43.1 thousand. So whatever 1990 was, 1991 was that specific number plus 43.1 thousand. 1992 would be 43.1 thousand times 2 plus 1990, and so on and so forth. Up to the year 2000, where there were 1529.6 thousand visits. So they actually are giving us a point there, if you think about it. If I do a graph here, and by the way, this graph doesn't always have to start at 0, 0, and it's not, because we know that this would be 1990, 91, 92, and so the year 0 would be all the way that way, basically 1,990 more lines to the left. So this isn't going to be your typical 0, 0 here, 0, 0, which means our y-intercept is also going to be a little bit different because this also won't be 0, 0, right? The y and the x both will not be 0, 0, so things will be a little different here. But anyway, 1990, 1992, 94, 96, 98, and the year 2000. And every year, 1990, this is year 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Every year it goes up by 43.1. Each year it goes up by 43.1, which, by the way, sounds like slope, doesn't it? Up 43.1 thousand, up 43.1 thousand, over to the right by 1 year. So it's not truly a, it's not a 1-to-1 ratio, but it's still going to look like that. And how many people were there in 2000? 1529.6. 1529.6 and 2000. That's our point. This is actually an x y coordinate. So what is it? It is 2000 and 1529.6. So this is the part about real applicability to life. You know, it's real life here. So although you're probably wondering, who cares about the number of visits to the park, and that's different. But there will be other areas in your life that you can actually apply this to. And you may not have to do it specifically like this, but if you're thinking in these terms, it'll make it much easier for you. So, y equals mx plus b. We actually have a point now. This is our point, 2015.29.6. 1529.6. And we have a slope, 43.1. Y equals 43.1 x plus b plus the y-intercept. And the y-intercept, anyway, okay, so the y-intercept happens to be here, but again, it's not 0, 0, okay? So, let's plug in our points. We go to 1,529.6, which is thousands, but that's neither here nor there. 43.1 times the number 2,000 plus b. We continue. 43.1 times 2,000 is 86,200. So 1529.6 equals 86,200 plus b. Again, 43.1 is our slope. We go 43.1 thousand for every year. And we have this point, the year 2000, which we did time on the x-axis. This is your x-axis. And we did numbers on the y-axis. And each year that we go forward, we would add another 43.1 thousand. So, I'm going to take 86,200, and I'm going to subtract it from both sides. And I get 1529.6 is 84,000. Negative 84,670.4 equals b. I'm going to rewrite my slope-intercept form linear equation as y equals 43.1 x minus 84,670. So, what am I trying to do? I'm trying to find out the number of people in 1990. I believe that's the question, right? Write an equation that gives the number of thousands of visits as a function of the number of years since 1990. So for me, this is your answer. Y equals 43.1 x minus 84,670. That's it. And now, if I plug in 1990, if we're curious, I get 1990 times 43.1. Just if I'm messing around here for fun, equals minus 84,670. Y equals 85,769 minus 84,670. And Y equals, in 1990, 1,099. There you go. That's your answer. For 1990. But they're not asking for 1990, so I'm not worried about it. But it does make sense, because if you go back to the year 2000, you can draw this line here. Each one of these years is minus 43.1 from that year. And it's actually 10 years down. So if I take 43.1 and I multiply it by 10, it'll be 431. If I subtract that from 1529.6, I'm going to get my y-intercept, which is the number of people that went to the park in 1990. Okay? So, anyway, that's just added information. How many visits were made to the park in 1995? Well, I take my formula and I plug in 1995. So, y equals 43.1 times 1995 minus 84,670, and 43.1 times 1995 is 85,984. I subtract 84,670, and I get 1314. And folks, that actually sounds right. 1995, so 1, 2, 3, 4, 5, right there. That means this right here is 1314.5. That's your answer. 1314.5. And when were there 1,400,000 visits? Well, I'm now going to take this same equation, as I did before. And they're asking me, when will the answer be 1400? I plug in 1400 equals 43.1 x minus 84, 670, and I solve for x. How's that sound? Add 84, 670. See this? We're isolating 43.1x, just like we did in all our other that we've done in our past math classes. We're just using real numbers and much bigger numbers. 84, 670, and 84, 670 plus 1400 equals 86, 070 equals 43.1x. How do I isolate x? I divide by 43.1, and I get 1996.98, which basically means 1997. And that would be right there. And that is 1400. $19.97. That's it, folks. 19. Okay, so there is a method to this madness. And if you start slow and you think about what's the slope and what you're looking for, the y-intercept, you can create a problem. And then you can plug in numbers to find answers. All right, and now number 16. You have $5 to spend on guitar picks. You want to buy some nylon picks for 35 cents each and celluloid picks for 25 cents each. So I see two variables here. Standard form is what jumps out at me. AX. So I'm going to have a number of the price for one of the picks. We'll call this the nylon picks. Nylon picks plus BY, and we'll call this the celluloid picks. And again, this will be the price. A and B are the price, the numbers, if you will, equals some dollar amount. And the X will be the number of those picks. And the number of those picks. So price, and then number of picks. So let's see. So how much am I spending in total? I'm spending, folks, $5. And I see the nylon picks as 35 cents. So 35 cents X. We don't know how many nylon picks. Remember, we call these nylon picks. Plus, and you could actually do 35 cents N if you want. It doesn't have to be X. Plus 25 cents Y, AX plus BY, and that is celluloid picks. And that's really what you're looking at here. And you really could just say 35 cents N, nylon, plus 25 cents C equals $5. And this might actually even make it easier. N and C, nylon and celluloid. You don't need to always call it X and Y. These are just typical variables that we use, but they don't have to be the X and the Y, that is. Write an equation in standard form that models the possible combinations. This is it right here. That's your answer. And that's A. And then B is list 3 possible pick combinations. Okay, so if I say N equals 0, I buy no nylon picks, I wind up getting 25 C equals $5. Well, there's no nylon picks, so I get 25 C equals $5. I divide both sides by 25 cents. And C equals, well, we know 25 cents. I'll just do it. 5 divided by 0.25 equals 20 picks. And that makes sense, right? 20 times 25 cents is $5. I can do the same thing. And by the way, this is you are finding the x-intercept if y equals 0 and the y-intercept if x equals 0. So you're finding the c-intercept if n equals 0, and you're finding the n-intercept if c equals 0. So I do it again, 0.35. And let me just bring this down here. Copy, paste. And now I'm going to say 0.35n plus 0.25 times 0 equals 5. 0.35n equals 5. And then I'm going to divide both sides by 0.35. And 5 divided by 0.35 equals 14.28. So I can't buy 14.28 picks, right? N equals, no one's selling me 0.28 of a pick. So I can buy 14 picks, and I'll be left over with a little bit of change. That makes sense? And then I can do one more. I can do copy, paste. I can just plug in a random number, 0.35, but I can't plug in a random number over 14 or over 20 because those are our maximum when the other one is 0. So I have to pick a little bit less. So if I pick the number 5 plus 0.25c equals $5, 0.35 times 5 equals $1.75. This actually works out perfect. Plus 0.25c equals 5. So I plugged in a random number for the n, and I'll get some number for c. And the reason why I said it worked out perfect is because this right here is in quarters, and this is also in quarters. So it'll work out to a perfect $5. So I do 5 minus 175 minus 175. I get 25c equals 325. And then I don't really have to use a calculator here. I know that every 25 cents in $1 is 4. There's $3.25, so it'd be 12.13. But you can use your calculator. 325 divided by 0.25 equals 13. And so if you buy 5 N's, you can get 13 C's. That's it, folks. And again, if I picked over 14 picks that were N's at 35 cents each, it would have gone over $5. So I would have gotten a negative number for C. And you can't get a negative number for C because you're not giving them picks, which is what that would mean. So there's some rational thought here. Anyway, that's it. I hope this makes some sense. If it doesn't, go over it slowly again, and you can maybe figure it out. And if you want to learn more, reach out at any time. That's it. So have a great Thanksgiving, and I will see you on Monday. And if you owe me any work, send it in. Have a great day. See you, kids.